All right, in the last video, we talked about contrastive learning, which is something that you add into your toolbox with respect to solving computer vision related problems. All right, in this particular video, we are going to be putting almost everything we've learned so far together into actually building a computer vision system. So in a situation whereby now you've learned, image processing, video processing, and the likes. So the question now is, how do you build a computer vision system? A system is different from the model. It's different from the processing. A system encompasses everything altogether. All right. So in this particular video, I'll be walking you through how to efficiently build a production-ready computer vision system so that after this course, you are able to build your own computer vision system and deploy for people to use and for people to test. All right. I want you to find out how to do this by listening attentively to this class.
Hello, so welcome back to class. All right, in today's class, we are going to be looking at which is deploying and building computer vision systems. Um, Basically, we've learned a lot of things in the last few weeks, talking about how we can. So, welcome back to class, to computer vision systems and the likes. So, what exactly are the things we are going to learn in this particular class? Number one, we are going to learn about computer vision and software engineering. Like, what is the balance? Where is the integration? All right. We're also going to look at media storages, S3, AWS, AWS S3, Cloudinary, because we are dealing with images, we are dealing with video files. So where can we save video files? Where can we save image files in order to process our media data? Then we're also going to be looking at how to handle requests. Basically computer vision and software engineering, but the software engineering, which is the back end or the front end, what's the link? So that is where handling of request comes in. Building your app as a microservice and then converting it into a Flask app or a Dapper app or something. So handling of requests. Then we're also going to look at database. That is, we're going to look at the different types of database, TiDB, MongoDB, just to make you have an idea of the kind of data we are dealing with. Then we are going to also take a look at Kafka, Redis. We're just going to talk about it. We're just going to talk about some of all these things. So we are trying to look at how can we build an end-to-end computer vision system. We've been talking about the modeling. We've been talking about the research. Most of the models I was referring to the papers, in order for you to have a better understanding or better comprehension of what they are trying to achieve. So now is the practical, right? We've built the model, we've trained the model, we've optimized the model, we've done all of those things. So now the question is, how do we deploy, or how do we deploy a computer vision system with respect to softwares and likes? What's the link? We're also going to look at, I'll talk about PySpark. All right. Then I'll talk about data warehouse, Delta Lake, Databricks, and some other things. Then we'll take a little look at DevOps, SCADA, Docker, Kubernetes. I'll just talk about some of these things. I might not be able to go into details with respect to how to practicalize or how to use them, but I'm just introducing you to some of all these things that you should be aware of, or that you should at least have an idea of how these things work in order for you to be able to build a computer vision system. Of course, definitely some of those things are data engineering, some are DevOps, some are backend, but sometimes it's good as an AI person to have understanding about some of all those things. All right. So what do I need to know as a computer vision engineer when it comes to software engineering? Like, how do I work with software engineers as a computer vision engineer? So in computer vision, after developing or evaluating your model, you need to do the following to get it into production. So you need to do model optimization for production, okay? And that involves the following. Now, model that you built locally is different from models that you push into production. So there needs to be some further level of optimization, because you've been able to test it locally and it's doing so well. You are impressed by the performance, but that doesn't mean that's the way it's supposed to work in production. So there needs to be some level of optimization and the likes. So first and foremost, with respect to model optimization, is model compression. So in production environments, the model size and inference time are very critical. Techniques like quantization, pruning, distillation can be used to make the model smaller and faster without significant loss in performance. I would love to recommend that you check out model quantization, model pruning, model distillation. They are topics and subjects on their own for you to be able to understand how to take a model from local to production. All right. Definitely in this particular video, I'm going to be demonstrating how you can actually implement or just put some of all these things together. It's just to give you a clue of how you can deploy a computer vision system integrated with software engineering, just to give you an idea of how these things work and how there should be some level of interaction. But nonetheless, you still need to do more of learning and understanding on how to achieve some of all these things. That's the reason why I'm teaching you with respect to model compression. So model compression on its own, it's a subject on its own. It's supposed to be a video on its own. So techniques like quantization, pruning, distillation are key subjects. In fact, there are codes that shows you how to do quantization, pruning, and distillation, which I won't be covering. So I would love you to go the extra mile of studying how to implement them. Another thing that you need to be concerned, or that you need to understand with respect to model optimization for production level deployment, is edge deployment. So when we're talking about edge deployment, we are talking about if the model is to be deployed on an edge device, e.g. a mobile device, a camera, Internet of Things device. So there has to be some level of further optimization. So further optimization might be necessary, and sometimes this can involve converting the model to run on specific hardwares like mobile GPUs or specialized chips like TensorFlow Lite for mobile. All right, so these are things that you need to be very aware of. Then another thing you need to consider with respect to model optimization is hardware considerations. So select appropriate hardware, such as GPUs or TPUs or specialized accelerators for high performance inferencing depending on the resource constraint of the system. There are some computer vision systems that probably they might not need GPUs. They might need TPUs, and some they need GPUs. Okay, so the question is, how do you deploy it in such a way that they keep running effectively and there's a very maximum response time? Because imagine a user uploading for instance, a user is trying to use your computer vision app. The person took an image, is expecting a response, and it's taking roughly about 1 minute for you to get a response. Building such kind of products, it's a red flag for users, because users are always impatient and they want results as fast as possible. So once they upload an image, they want result in 1 second, like if possible in milliseconds. All right, so there are some times whereby they could be compromised with respect to some of those things, whereby maybe you don't have a lot of GPU constraint or considerations and you have to make some. So it depends on your type of users also. All right, so if you are dealing with end users, definitely you know that your response or your data, your information has to be extremely fast, if in less than seconds, in order for them to have a maximum usage of your products. All right, so basically, I would love to encourage that hardware consideration is one of the things that you need to consider when you are building a model or you are trying to optimize a model. Now, integration with backend systems. Computer vision systems are very, very easy to integrate when you are dealing with backend systems. First is API development. A common approach for deploying computer vision models in production is to wrap the model into an API using Flask, Fast API, or Django, or maybe Dapper. All right. The API handles requests from client applications, perform inference using the computer vision model, and sends back results, e.g. object labels, bounding box, segmentation. So you can actually build more or less like a backend that is wrapped around the model in production, such that the API handles maybe an image, and then the API takes that image, downloads the image, reads it from file, reads it into file, then feeds it into the model. The model does a prediction and is generating maybe object labels or bounding box or segmentation. So there's a format by which you send the model back. So the API makes that you make that request through that particular API, and then you get your response. So you really want to build a computer vision system that is efficient, such that when you make API calls with respect to the model that you've deployed, you want your response back. And that's the essence of integration with backend systems. The reason why we're having all this conversation is because you've built a computer vision system that works on your local, and you want people to be able to use that particular computer vision system in a product, or maybe in a software product, definitely. Or maybe you're trying to build a personalized project, or you're building as an hobby, or you are part of a software development team, and you want that computer vision project, computer vision model to be used. So these are some of the things you need to be aware of when it comes to integration with software engineers. Now, we also have microservices. When you're talking about integration with backend systems, we also have microservice architecture, which is one of the major architectures where Dapr falls into. Dapr is DAPR. So I'll talk more a little bit about that, because I want us to actually design a computer vision system, that takes a text and generates an image. So imagine you have a front end whereby you have your users just use your app, they just want to play around your AI. So they upload a text, or they send a text to your AI, and you expect your AI to generate some certain level of image. All right, so that's something like what we are going to be doing at the end of this video. So microservice architecture. So for scalability and modularity, the computer vision model can be deployed as a microservice, separate from other backend services. This allows the computer vision service to be scaled independently based on demands. Now, I want you to know that, I think we'll talk about cloud platforms like AWS, right, where you can actually deploy your model and the likes. But I'm just talking about some of all these things, some sensitive things like model pruning, you have to go dig deeper in order for you to have more understanding on how to use them and how to apply them to your current project. Now let's talk about model deployment frameworks. So we are talking about integration with the backends, right? The next thing is model deployment frameworks. So how do you integrate your computer vision with what are the other things you need to take note of is the model deployment frameworks. So platforms like TensorFlow 7 or Touch 7. So if you wrote your code or your model in form of PyTorch, or you built the model as you wrote the code in TensorFlow, right? You can, if it's in TensorFlow, you use TensorFlow 7. If it is Touch, you can use Touch 7, or you use MLflow, Kubeflow, which can be used to serve models efficiently. These frameworks handle inference, request, manages models, and provide monitoring capabilities. So you might want to check out Kubeflow, MLflow, Touch 7, TensorFlow 7. These are concepts on their own. This is to keep you informed with respect to how to efficiently build a computer vision platform, taking into consideration all these key things. Now, deployment to production environment. Let's talk about deployment to production environment. So we have cloud deployment. So if a computer vision system doesn't need to, if the computer vision system does not need to run locally, that is on an edge device, it can be deployed to the cloud. Popular cloud services for model deployment includes Amazon SageMaker, Google AI platforms, or Azure ML. Now, Amazon SageMaker, Google AI platform, Azure ML, they are very popular cloud platforms that you can actually deploy your models to, and they give out a lot of credits, GPU credits, that you can actually leverage on in order for you to deploy your model. But this service provides infrastructure to deploy, manage, and also scale your AI models. There are situations whereby the reason why we're talking about infrastructure, because when we're talking about AI, definitely you're going to be having influx of requests from all your users or all your customers or anybody that comes across your products, and are going to be making requests to your platform or to your infrastructure. So definitely you need to be able to build an infrastructure that is so much robust in such a way that it can manage a lot of requests, and it can scale when there's so much request, and then it can also scale when there is less request. So you really want to ensure that you have it, and that's the aspect of DevOps, okay, which doesn't really concern computer vision guys, but it is very, very important that you have an understanding of how these platforms interact with your computer vision model, so you know how to build things better. Containerization. Docker containers are commonly used to deploy ML models. The model and its dependencies are packaged into a container, which can then be deployed anywhere. Ensuring consistency across environments. Kubernetes can be used to orchestrate containers in a scalable way. So what we're trying to talk about here is that you can actually have a model that runs in a Docker container using GPU on an hardware device. And then when you have containerization is actually very, very important. You don't want to expose your models anyhow. So containerization is very, very important when you're talking about cloud deployment. Now, the aspect of Kubernetes is that it takes your Docker container and then it scales it. So we call them pods. So in this case, your containers becomes pods. So in situations whereby a pod is not able to handle the request or the incoming, a lot of those requests, it can create more pods, which is the same thing as the same container. So it duplicates and replicates itself into more pods in order for it to be able to handle more requests. And there's what we call CADA. So CADA is one of the technologies. I'll literally have to talk. So I want to talk about some of these technologies maybe once I'm done with this slide. So I'll just talk about some of these technologies that you need to be aware of or have an idea of when it comes to deployment or scaling computer vision systems with respect to the software engineering aspect of the system. Then we also have CI/CD pipelines. That's continuous integration. All these things are more of DevOps actually, but having an idea is a great knowledge as a computer vision person, and it makes you stay relevant. So continuous integration and continuous deployment, that is CI/CD pipelines, are set up to automate the process of testing, validating, and deploying new versions of the model. This ensures smooth updates to the model and systems with minimal downtime. Now, the reason why it is very, very important that your system or your computer vision model has a CI/CD pipeline, that is continuous integration and continuous deployment, is that your model would always need improvement, okay, in order for your users to be satisfied. Definitely your model needs to learn more from users and so many other things. So in a situation whereby the current model deployed is version 0.01, and now you have a new version 0.02. So the question is, how do you update the current deployed version from 0.01 to 0.02? CI/CD is what makes that happen, and that's DevOps. So literally, you train your model, you push to MLflow or to Kubeflow, and then of course, the DevOps person just takes care of things from there. All right, in order to properly manage the different models. And there are situations whereby a model could be failing in production, even after going through a lot of evaluation, t-tests, A/B testing and the likes, and you might want to revert to previous models. So that's the essence and the usage of CI/CD pipelines, such that you can actually revert back to the previous system that was deployed that was not giving us issue to, so these are things that you need to be very, very aware of as a computer vision scientist in order for you to be able to work effectively with software engineers. So let's talk about monitoring and logging. Now, it's very, very important when you are talking about computer vision and software engineering. Just as software engineering keep track of everything, back ends, front end, they keep track of everything that is happening with respect to the front end or everything that's happening with respect to the back end. Computer vision engineers are also expected to keep track of how the model is performing in terms of it encountered this input data, it gave this result. It encountered this input data, it gave this result. Sometimes you also want to keep track of how many requests are you getting per second, how many requests are you getting per minute, how many requests are you getting per day. Now you need to monitor and log. Now when there's a failed response, what happens to the system, or what did the system do, or how was the system able to handle that situation. So there are a lot of essence with respect to monitoring and logging. So for instance, performance monitoring. Once the computer vision model is deployed, it is essential to monitor its performance in real time. Metrics like inference time, accuracy, system resource usage, that is CPU, GPU, very, very important, memory, should be tracked. This helps to identify and address performance bottlenecks. For instance, let's say you're deploying your system on a 100 gigabyte GPU RAM, and then the influx of all the requests that is coming in, your system is able to handle it, but it's only consuming roughly about 50 gigabytes. So it basically means that 50 gigabytes of your GPU is currently lying wasted. And there are situations whereby, let's say out of 100 gigabytes, your system is getting so overloaded that it's looking like as if you might be running out of memory or something, such that it cannot handle. It can only handle some certain requests per time. All right, and you want to increase the number of requests your system can handle. So situations like that, you need to increase the GPU limit or increase the GPU size. And in order to do that effectively, of course, there are other techniques, batching and some other things, to properly manage and also to make things faster. Okay, so it depends on the technology you're trying to build. And so you need to log the CPU usage, the GPU usage, the memory usage, because you really want your system or the whole infrastructure or computer vision infrastructure or software engineering infrastructure to be completely okay in order for you to be able to effectively build in order for you to be able to effectively keep track of everything that is happening, and for you to be able to know how your system is performing with your users using it. Another thing with respect to monitoring and logging is data drift and model retraining. So over time, input data may change, causing the model's performance to degrade. Data drift detection techniques are used to monitor shift in input data distribution. It performs drops. The model might need to be retrained or updated with new data. So these things are very, very important, which is the essence of monitoring and logging. So we also have logging, that is implementing logging mechanisms to capture details about model inference results, errors, and unusual events. This helps in debugging and maintaining the system. Now, let's also talk about the client-side integration. This part is actually quite optional, but I just want to talk about it, which is not really computer vision, but you having an idea of how these things link together. So when we are implementing the code, and I'm demonstrating how to build a very mini computer vision system and deploy it, you would have an idea of some of all these things. And when you're working with a software team, you need all these ideas, all this information. All right, so client-side integration, which is optional, that's mobile and web application. If the computer vision model needs to be integrated with a mobile app, that is an iOS or an Android or a web application, the model can either run on the cloud, that is the server side, or directly on the client. So when we talk about client basically means the user that is on the mobile phone. Then when we say cloud, it basically means where your deployments are on a remote server. That's the server side. So for edge deployment frameworks like TensorFlow Lite, let's say you are trying to deploy a TensorFlow model, you've trained or built a TensorFlow model and you want to deploy it. So edge deployment frameworks like TensorFlow Lite, CoreML for iOS, and ONNX, I usually call it ONX, can be used to run models for run models on mobile devices. All right. So Web APIs. For web applications, you might integrate the model via APIs where the front-end application makes HTTP requests to the backend to perform computer vision task. Then real-time inferencing for application requiring real-time processing like video surveillance integrated with cameras, surveillance cameras in your street or something. Video surveillance, AR and VR techniques like frame batching or multi-threading are used to ensure low latency processing. You want to build a system, or you want to ensure that your computer vision system is a system that ensures low latency. When we say low latency, it basically means high throughput, and it basically implies that your system is fast at responding to users' requests. So there's no delay. So the faster it is, the lower the latency processing, which is quite good. Then what are the other things you need to take into consideration with respect to computer vision and software engineering is security and privacy consideration. Data encryption, for instance. Ensure that all data being sent to and from the model, especially sensitive data like images or video streams, is encrypted to avoid security vulnerabilities. Alright, so this is very, very key. Now that you are dealing with computer vision system, you're also dealing with sensitive data like users' image or maybe some users information or something, or a user is giving you a proprietary video something, or maybe you are building a product and one of your users that your company signed an NDA with, that is a non-disclosure agreement form, they started sharing some of their sensitive video data in order for it to process for them. All right, it is very, very important that you ensure that all data being sent to and from the model, that is most importantly if their data is going to have to interact with your model, is encrypted so as to avoid security vulnerabilities. Then user privacy. So in cases where personal data is involved, e.g. face recognition, medical imaging, it is crucial to adhere to privacy regulations such as GDPR or HIPAA. Some of all these things is just for you to have an idea about some of all these things. It's not the core of computer vision, but it's just for you to have an idea. And then when you are building your solution, you build it with some of all these things in mind. You are not trying to build a model to just be vulnerable to any kind of data it comes across. You also want to ensure that you protect your model in such a way that it performs optimally the way it's supposed to perform. So which means input data that are going to be entering into your model has to be validated or has to be checked to ensure that the model would be able to perform as it's expected to perform. Because when you are feeding a model with data that it does not understand, it's going to give you jargons, or it's going to give you some errors. Now, if it bypasses a lot of errors and then it gives you a result, then that is some level of security vulnerabilities or security breach or data breach. So let's talk about scalability and load balancing, which is another thing you need to be aware of. As a computer vision engineer, when you're interacting with or dealing with software engineers. Now, security, that is scalability and load balancing. Now, horizontal scaling. So how do you scale your model? How do you ensure that all of these things is well balanced? So let's talk about horizontal scaling. Now, this has to do with to handle large-scale inference requests. That is when you have a large number of data that are popping up or that are trying to enter into your server for processing, e.g. processing thousands of images. So imagine you have to process 200,000 of images, all right? And you know that that's just a 90 minutes match, which is one video. So imagine you need to process 200,000 images. So how would you want to do that or scale it or ensure an effective load balance system? Right, so horizontal scaling is one of the things that you need to look into in order to solve that particular problem. So you have to handle large scale inference requests, deploy the computer vision in a load balanced environment with horizontal scaling. Cloud services like AWS, Google Cloud, and Azure provides auto scaling, and they also provide load balancers. Then batch processing, which is one of the things that we've always been adopting when we are running our model on some test data. So for high volume but non-time sensitive tasks such as processing a batch of images or videos, batch processing pipelines can be implemented. This allows the system to handle large amounts of data without causing significant delays for real-time tasks. Now, you always want to ensure that your system or each of your model input to your model goes as specific number of batch. The more the number of batch, the more the number of GPUs. So if you do not have a fixed batch number, and then all the data keeps coming in the way they are coming in, right? So literally your system will always run out of GPU memory. All right, so that's why we have horizontal level of scaling and also batch processing in order for you to help handle scalability and load balancing. Now, continuous improvement. One of the things that you need to do, or you need to be aware of as a computer vision person, is that you don't just build model and just deploy. You need to continuously improve the model. And one of the ways by which you do that is A/B testing. So you have to conduct A/B testing on new versions of the model to see how they performed compared to existing model in production. This helps in ensuring the model updates, improves performance without introducing newer issues. Now, another thing you also want to take into consideration with continuous improvement is user feedback. So use user feedback if available to continuously improve the system. So if the computer vision system is part of an application where users interact with it, e.g. labeling objects, identifying faces, their inputs can provide valuable data to retrain and fine-tune the model. Alright, so continuous improvement. Now, another thing you need to be aware of is what are the different tools and frameworks for deployment. 1. TensorFlow 7, a flexible high-performance serving system for machine learning models designed for production-level environment. TouchServe, it's an open-source framework for serving PyTorch model in production environment. ONNX runtime. Just pardon my spelling of it. It's a cross-platform inference engine to run ONNX models in production. Then we also have Kubernetes. I've spoken about those things, but you just need to dig a little deeper to have more understanding about them. Kubernetes is to help you for managing, scaling, and deploying containerized computer vision service in a cloud-native environment. Then MLflow, it's an open-source platform to manage the machine learning lifecycle, which includes experimentation, model tracking, and deployment. And that's the reason why it's a very good integration with CI/CD, because when you train your model and you feed it, do all of these things in MLflow, it can basically manage the different types of ML models that you've built, such that as you're experimenting, you are also pushing some to production, evaluating, and all of those things progressively. So in summary, what are we trying to talk about? Deploying computer vision into production involves a combination of model training, optimization, infrastructure setup, monitoring. All right. So once the model is optimized and packaged, it can be deployed on the cloud, on edge devices, or as part of a larger software system. So continuous monitoring, scaling, and updates ensure that the model continues to perform well and meets the needs of the end user. Integrating computer vision model into production requires careful planning of the deployment, architecture, security, and scalability to ensure high performance and reliability. All right, so before we go into trying out and hands-on or doing some level of hands-on, so we are actually going to build a computer vision. Let's try and build a computer vision system. So I will do a little bit of introduction to system engineering, just for you to have an idea of, or to have an experience of what it means to build a computer vision system and ship it into a software engineering system. All right, so we're actually going to be building at the end of this video, we're going to be building a computer vision system that can take text from users and generate the corresponding image of the text. But your assignment, how do the text to image part, your assignment will be to convert the text to video. So in this case, you are literally trying to build a computer vision system that takes a text data, all right, and generates the video illustrating those text, that particular text. All right, so basically, before I go into the coding aspect and the likes, I said I wanted to talk more about some of these tools that you need to be aware of, what they do, what they are. Though I've explained I've explained quite a number of them, but what we are going to do is we are first of all going to design the system. What does it mean to design a computer vision? So this is what we call system designs. So I'm just giving you an hint to some of these things. So system designs when it comes to computer vision is so we're going to design a system that addresses that text to image problem projects that we're trying to do, which we are going to do. We're going to practicalize. So first and foremost, let's go design the system so that we can understand how everything is connected to each other. How is MLflow connected to MLflow, Kubeflow? How is it connected to backend? How is it connected to computer vision model? How is it connected to the user? How does information flow and back to the user? So we're going to find out about that in a little bit. So I'm going to share my screen right now, show you how to design that system. Then after that, we're going to go into implementing the code with respect to that particular computer vision system. We might not implement everything because of time, but we are going to be able to demonstrate some key parts that you should be very, very aware of. All right, yeah. All right, so let's continue from where we stopped. Now we made mention of some certain things at the beginning that we are going to try out. So we want to be able to take a look at some of all these things. I want you to check out Delta Lake, Databricks. I won't touch everything, but let's not forget we are trying to build an end-to-end computer vision system that takes in the text data and then deploys and then returns the image describing the text. All right, so let's just assume we're going to be using Stability.ai, Hugging Face, some of their pre-trained models to be able to do that for us. So the question now is, I want us to actually design more or less like a computer vision system. Now, we already know what is happening under the hood, but primarily, let's talk about how this thing from user to the system and back to user. So how will all these things work? So let's have a high level overview. So I came here. So this is lucid.app. That is, if you go to lucid.app, you should be able to create diagrams, high level diagrams. So what I'm going to do here is that I'm actually going to look for some shapes. I'm going to look for user. So let me look for some shapes of users. Let me use this. Okay, so let's just call them end users. Now, end users are going to be interacting with our app using what they call they'll be interacting with our Streamlit front end, for instance. So because this is a machine learning system, so let's just say this is the front end. All right, but in this case, we are going to be using Streamlit. Okay, so your front end in this case, front end can be Next.js, Node.js, but let's just design a computer vision app. So there is input from users. There's input from users to the front end, and then from front end to user back. So there's an input and there's a response. All right, so now the front end has to communicate with the back end. All right, now in this case, the back end here can also be another shape of so our backend also can also be it can be a Flask app. Flask, that is Python Flask. Now, of course, there's going to be back and forth also. Okay, let's maintain the arrow direction. So I'm walking you through these things so that as a computer vision person, you have an understanding of how these things link up with each other, communication across some of all these platforms. All right, now Now that we have the backend, now the backend is a Flask app, which is, so the front end is going to be making API calls to the backend in order to be able to, that is sending text to the backend and via API call, and backend returns the response to the front end. All right, now backend needs what we call DB, database. In this case, it's either we are using a TiDB or a MongoDB to store data. So one is SQL, one is NoSQL. So I want you to go check that out. But let me just, so there has to be input from the DB, and then of course communication from the backend. There's going to be communication from the backend to the DB. Then of course, since we are dealing with image or video data, so we need a storage. All right. So let's say we need data storage or media storage. So in this case, for media storage, is either we're using AWS S3, or we are using Cloudinary, or we are using what they call this image URL to be able to save. Now, okay, let me, I think I just have to just draw closer. All right. So basically, this is a simple demonstration, and of course the backend is communicating with our AI. So this is where the computer vision model is sitting on. Now, so I'm just illustrating the basic flow, so that when you are building, so this is the basic flow. So we have the user, we have the front end, we have the back end, we have the DB where you are saving records. So when people sign up, backend saves the record of the sign up, and then when you need authentication to get signed up, you also get that from the backend handles that. Then the backend also, if it needs to save image URLs, because this one could be keeping the URL, but this one is actually the URL. Is backend is keeping the URL in the DB, but the actual image URL is saved via media storage. Now our computer vision model is fetching its information from the backend. Now there's going to be, now this is the basic. Now let's try and expand things a little bit from the basic. Now this computer vision model is going to be dealing with MLflow. Now, by the way, I will want you to check out MLflow. So some of this, so for instance, if you search for MLflow, this is simply MLflow.org. So ML and Gen AI made simple. Run ML and generative AI projects that solve complex projects. So they have a docs, they have a way to get started, ML documentation. Basically, it's more or less like a pipeline for building models and then sending it to your deployment. So you might want to check them out. You might also want to check out their documentation on how to implement tracking, prompting, evaluation and monitoring of your model deployments and likes. Now MLflow is also similar to Kubeflow. So I want to explain how some of these technologies, how they link. So Kubeflow makes artificial intelligence and machine learning simple, portable and scalable. All right. So the machine learning toolkit for Kubernetes. All right. So Kubeflow makes artificial intelligence and machine learning simple, portable, and stable. Well, ecosystem of blah blah blah. Deploy Kubeflow anywhere you run Kubernetes. All right. So it supports Jupyter notebooks and the likes, such that you can deploy. There's also case serving, more or less like TensorFlow serving, AutoHLML. You know, there's model trainer. So these are packages, softwares, documentations that you definitely want to explore on how to use them. Then I also want to talk about one more thing, DAPA. So DAPA is literally distributed application runtime. So it's more or less like a micro. It's APIs for building secure and reliable microservice. So it's in a situation whereby you are trying to have a message broker, you can have DAPA as an API that encapsulates your message broker, or you have an application, you have DAPA to encapsulate. So it's a microservice. So in a situation like this, what we have here, we can actually have our database running on DAPA, our media storage running on DAPA, our backend running on DAPA, front end running on DAPA, our computer vision model running on DAPA, such that they are all microserviced. So what I will do is, let me just go ahead and get the DAPA logo, so I can just attach it to the logo. So I can attach it to this so what I'm trying to do here is, where is it, Lapa? Okay, so I'm literally trying to say, okay, this thing is running on DAPA. Our front end DAPA. What we're going to be implementing is not going to be this complex, but of course I want us to pay more attention to the computer vision. Then of course I can also add AWS or Cloudinary or something. So you can actually write a package, Python package on AWS, Cloudinary, or Image Girl. Alright, now another thing is, between the backend and the computer vision, which is one of the major things I want to talk about, is now all of this is sitting on the CPU. All of this can sit on the CPU. So let me bring this. All right, so let me send this to back. Send that thing backwards, send to back. Now look at this. This is the CPU. So let me add text. Okay. All right. So this text, let me make it. I want to color it up. Let me just say black. Let me say black. Bold. Here's this color thing. View. Select. File, insert, arrange, share. Okay. I'm trying to get what they call this thing. Okay, so basically I'm trying to, let me make it just bigger, maybe that would just cut it for us, because I'm trying to allow the white, so instead of it on a white, I'm trying to change the color of the text. So I want to give it different color. I think they've made some adjustment too. So it's been a while since I used this though. Now this is the CPU. Now let's duplicate this, and this is the GPU. All right, so let me send this to back. Arrange send to back. Now in this case, computer vision, in this case, all right, now this is CPU, now this is GPU. So this is more or less like system high level design. Now another thing that we can also do is, we already have the CPU, right? We have the GPU. So now all of these are running on an hardware called CPU. They are running on an hardware that is CPU bound, and then this is running on hardware that is GPU bound. Now sometimes this has to keep running, sometimes this needs to run only when this guy is receiving, only when there's data to process. Now between the backend and the computer vision model, these things are on two different, now end users is what they call it, they are outside the CPU or GPU. Now there's going to be what we call what they call this thing, let me see, Kafka broker. So now message broker is what we call a Kafka is simply what we call message broker. We also have RabbitMQ. So communication between, you can actually have communication between the backend and the computer vision model using DAPA, all right, which is image URL. And then, but the thing is, messaging in this case, we want to use Kafka. Now Kafka producer, or let's just say Kafka consumer, and then Kafka producer. I don't know why I can't edit this thing. Let me just increase the size. So we have Kafka consumer, but in this case our Kafka is, let me, I'm trying to connect this to this. Why is this stuff not showing? That's one of the reasons why I like to use colors too. It's been a while I used Lucidchart though, but I hope I'm able to find a way around it. See what I'm looking for. Good. And this is what I'm looking for too. I don't know why Then of course this. I'm going to explain. Then we have the Kafka producer. But normally it's supposed to be able to pick it and just auto fix. So let me just delete this. So in this case, yeah, good. So let's bring this back. Good. Or better still, let me just put it like this. Then bring GPU in like this. All right. So now okay, let me rearrange it. Good. Now this is more or less like a system high level overview of what is happening. Now we can also have Kubeflow, which is where you are getting Kubeflow or MLflow. All right, which is where you are running your experiments and you are feeding in all models into your computer vision model. So this is where you run your experiments or something. So Kubeflow allows you to have Jupyter Notebook and then push your Jupyter Notebook into production in this case. So you might also want to check Flowhout. Let me check. So I've spoken about Flask, AWS, Cloudinary. Now data warehouse, I will leave that to you to go check it out or get to know more about that. So data warehouse like Databricks. So Databricks build better here with data-centric approach. Great models are built with great data. So it's more or less like okay. So with Databricks, you can actually save your data, store your data, and they have a lot of packages that helps you properly handle data when it comes to streaming and some other things. Then I also want you to take a look at Delta Lakes or Lakehouse. So Delta Lake is an open source storage that enables building a format agnostic lakehouse architecture with compute engines using Spark. So for instance, let's say you are trying to work with some data, and this is actually data engineering side of things, but you just need to have some idea about some of all these things. So it's an open source storage framework that enables building format agnostic lakehouse architecture with compute engines including PySpark, Spark for instance, like PySpark in Python, PristoDB, Flink, Trino, Snowflake, Google BigQuery, Python, Redshift, Databricks, Azure Fabric, API for Scala and the likes. And then also try and familiarize yourself with what they call it, TiDB. So TiDB is a type of DB for basically for structured data, and it's being used by a lot of big and top companies today when it comes to SQL database. So it's an SQL kind of database. MongoDB is a NoSQL kind of database. That's a document based, a developer data platform, but it is document based kind of DB. All right, now we have our Kafka running. So literally we have ourselves a system, or more or less like a bird eye view system. Now another thing with respect to this is that all of these things can be running on Docker. So let me just download the Docker logo. So let me just use this one, save image doc. So let me just call it doc. All right. So in this case, I'm just going to say, oh, this one has, so we can have that our database running as a Docker container on its own, right? We can also have our front end running on its own Docker container. We can also have our back end running on its own Docker container. We can also have our storage, or we can have a container that handles media storage. We can have a container that handles our computer vision model. All right. And of course, we can also have Kubernetes. So what happens then, we also have what we call Kubernetes. You might also want to look into Kubernetes. So I'm just trying to show you how some of all these things tie together. Now, there's what we call KDA. So let me just get the KDA logo first. Then I'll talk a little bit about it. So KDA, I'm introducing you to some of all these technologies so that you can go back to learn more about them. So let's talk about KDA. So KDA is a Kubernetes event-driven autoscaler. All right, with KDA. So let me just get the KDA logo here, and let's put all these things together. So we can say KDA is operating our database. KDA is dealing with our, so I'm going to tell you, so our backend KDA, let's say our media storage KDA. You can also have our computer vision model running on KDA. So now, KDA is simply Kubernetes event-driven autoscaler, and what it does is that it takes a container that is running Kubernetes, or a pod, right? So when there's so much influx, so for instance, if backend is making a lot, so if front end, if we are having a lot of users trying to access our front end, KDA creates more autoscalers, more front ends on that same domain, so that we don't have slow front end. So it expands the strength of the front end to be able to take in all those influx of engagement and the likes. The same thing for backend. So by the time front end is making a lot of requests, so backend is getting too many requests from the front end, and it needs to send requests back to the front end. KDA increases its size, so the more the influx of messages, the more the performance of the more it automatically scales, so that it can process all those information, of course depending on your CPU capability and all of those things, which is one of the things you are tracking. All right, so for tracking, there are technologies like Prometheus and Azure Monitor and the likes that you can actually use to track. And then for logging of your code base, you can use Sentry. You might want to check out Sentry. So when you're writing a code, and so when there's an error with your code or something fails in production or something, Sentry can actually help you keep track of how your code base is running in production, and you can basically see the logs. So basically that is what we mean by having a system whereby, so this is more or less like an high level. If I want to go deeper, I would have actually broken down these things into it, but basically we know that the technology we are using here is PyTorch and Python. So of course the GPU here is in PyTorch, the backend, the CPU, everything running on CPU, they are all in Python. All right, so I've been able to establish a few things. This is how computer vision system communicates with the GPU side of things. So which means, as a GPU, as a computer vision person, you must be able to write your program or write your script in such a way that when a DevOps person or your backend person or your technical lead gives you a Kafka consumer URL that is sets up Kafka on one of their servers, and they tell you that, okay, let's start let your GPU spin up the GPU instance, or let's say this GPU is running on AWS. So let's just say AWS is our provider when it comes to GPU. Yeah. So I'll put AWS here. So let me get AWS logo. AWS. Let me just get AWS logo. Save image. AWS. So like I said, this is just pure demonstration. Nothing. Okay, it's here. So now this GPU or this computer vision model is running on AWS. We can also have Azure. Like it can also run on Azure, not just AWS, SageMaker or something. We can also have Azure. We can also have Google platforms, GCP. So this can be hosted on GCP, whereby it is using the GPU. This can be hosted, let's just assume, DigitalOcean or any CPU, CPU cloud, any cloud hosting platform like DigitalOcean. All right. So now, thereby, so if these are running on a CPU containerized, so when users access your platform, they are able to receive flux of engagement. Now, I also want you to have an understanding that front end in this case, we are using Streamlit. It could be Next.js. All right. Front end in this case also have some authentication between front end and back end. So there are a lot of Apache technologies that you might want to take a look at to understand, like Apache API 6 gateway. API 6 gateway by Apache allows to manage the kind of API request that goes into the backend from the front end. So it does some verification authorization so that not just anybody, right, is making API calls to the backend. So thereby installing some level of API security to our API calls. Because if your code base is exposed, whereby somebody knows your API, because they know your backend URL, there's a very, very possible way whereby they can actually start making API calls to your system. Thereby, your system is getting a lot of GPU overload, whereas it's not coming from your users or it's coming from an hacker. All right. So it is very, very important to understand that computer vision systems is not just anyhow system. It's also another level of software engineering system. It's a more delicate aspect of software engineering system, whereby you have to understand how to keep data communication between your server side. So this is the client side. So in this case, this can be mobile, this can be web interface, but in this case, I'm just assuming web, for instance. And then this is the computer vision side, which is the GPU interface. So now I've been able to establish that there can be auto scaling, there can be data protection incorporated into some of all these things. So I just had to give you a high level, because I could have actually broken down some of all these things a little more. So I used all these things to give you an understanding of what DARPA is actually doing and why we are containerizing and microservicing some computer vision systems. And then how do we handle influx of data aside from batching? How do we handle a lot of influx of data? You can actually handle all those things using CADA, autoscalers. There are also scalers like CADA by AWS. All right, so you might want to check out don't forget some of these things are running on GPUs. So, and this is one of the things that makes this system different from systems like this that are running on CPU, because they don't need GPU. GPUs are more expensive. So which means cloud platforms like AWS, GCP, Azure ML cloud platform, Lambda Labs, Runpod, and the likes are GPU. They can provide you GPUs whereby you can host and run your experiment or run your stuff in deployment. All right, so I hope you've been able to learn one or two things with respect to this. Next is I want to actually now implement more or less like a simple backend, not a full-blown backend, more or less like a simple backend that so I want to implement a simple computer vision app that has a front end implemented as a Streamlit, whereby you enter the text and then you have the Streamlit leverage on the usage of Kafka. So in this case, the Streamlit is actually both the front end and back end. So instead of writing a Streamlit for front end then Flask as back end, just for the sake of demo, it's because of I want to explain, that's why I had to go this deep. But I don't have to necessarily implement it this way. But since we're already implementing and deploying and there's no front end that wants to write in Next.js, we can allow Streamlit to be our front end and also be our back end. So the Streamlit displays the front end, the user enters the text goes into the into Streamlit, then Streamlit with Kafka consumer produces the message, that is uploads the okay, it doesn't need to upload anything, but of course database, like if you need to save anything into the data, but right now we might not need to do that because we are just trying to build a system and demonstrate it. You could only talk about database when you now have multiple users or a lot of users, but this is just us just trying to test this thing. All right, and that doesn't cover the domain of what we are trying to do here. So the Streamlit produces the message from the user, which is coming from the Streamlit frontend, which is the text, to the computer vision model via Kafka. So the computer vision model reads the message via Kafka broker from the consumer. So the Streamlit is producing to the Kafka consumer, which is the consumer of the computer vision model, and it is receiving response from the model through Kafka producer, which is the producer of the computer vision model. So it's listening for events or for the response from the user or from the GPU model in this topic. So you might want to check out message brokers and understand some of all these things. Then when it gets the rest, but in this case, I believe that this part, which is media storage, is more going to be needed. So let me just move this. Well, let's just put it back in. So not necessarily with backend though. All right. What I'm trying to do here is that. Okay. It's the computer vision model that will need to upload to media storage and also download to media storage. So actually it's both. Backend needs access to, come on. So it's actually both. Then also computer vision, let me just move this a little bit back. All right, just a minute. All right, so let's put this back. Let's put this back. Okay, good. So the reason why I didn't move it was because the GPU doesn't need to be hosted on the GPU. It just needs to be on the CPU, such that via Dapper it can make a request to be able to upload a media, like maybe an image or a video. So that URL is sent back to this model, which is now sent back through Kafka Producer. Then this guy listens to this particular funnel. If it needs to save information, it saves it into the DB, and then it displays the image to the user. All right. So now that explains the end-to-end process with respect to the project we are trying to build. So right now, next, which is what we're going to do right now. So we're going to implement the Streamlit. The Streamlit is going to make the production connect to Kafka, the message broker. So and then I'm going to in the next video, I'm just going to go straight to writing of the code. Looking forward to seeing you in the next class.
Congratulations, congratulations, and congratulations once again. I want to say that yes, you are an amazing computer vision engineer, because you're not just a computer vision engineer that can analyze images or analyze video. You can actually build a production ready system. You have an idea of what it means to build a production ready system. Yeah. In this class, you've learned computer vision system end to end, from the data pipeline, the data processing, from the user endpoint, end of the system, up to the modeling, the inferencing, and the turning back the results to the user. You've learned all these things, and I want to say that you've done quite outstandingly well. I'm so proud of you. All right, it's going to be an assessment of everything that you've learned in today's class. I want you to follow through the instruction given in the classroom, and I want you to take it step by step. Try to build your own computer vision system, and I look forward to seeing what you come up with. I look forward to seeing the amazing things you're going to be doing with this particular class.